All right, hey guys. So today is Friday, the 8th. So we're just gonna be working on these 2 pages here today. I'm actually going to be doing all this stuff with you. So the plan here today, as we go through this, is we're going to look at this. We'll talk about this, make sense of it. When we get to the back page here, we'll introduce the problem. I want you to actually pause it, do the problem, and then I'll do it, and then we'll compare strategies. You might have a different strategy, and that's okay. And then we'll see how we got and how we did with it all. So let's go ahead and get started here. All right. Okay. This example, because we need this example to answer numbers 1 and 2 here. Number 1 says, the example says, there are 4 packages of printer paper to be divided equally among 6 classrooms. How much paper will each classroom get? There are 4 packages for six classrooms to share, which is 4 divided by 6, right? So again, 6 classrooms, let's just say there's the 3 fifth grade and the 3 fourth grade, right? So that's a total of 6 classrooms. And let's say the office only gives us 4 packages of paper to share amongst us. So the idea is we're all going to get less than a whole package, right? Because there's more classrooms than packages. In this model here, so obviously the problem is going to be 4 divided by 6. 4 packages divided amongst the 6 classrooms. So in this model here, here's our 4 packages. Remember, we want to model what we have. What is being divided are the packages of paper. So here's our 4 packages of paper. It's divided into 6 parts because there are 6 classrooms. Imagine this being classroom 1, classroom 2, 3, 4, 5, and 6. There's 6 classrooms. Now, this isn't literally how they're going to be divided. This is just showing mathematically how it can be divided. That each class is going to get one of these sections, right? Then each class is going to get one of these sections. Each class. So how much would each class get? Well, class 1 would get this 1, 2, 3, 4 parts, right? 4 parts. Well, each part is 1 out of 6 parts, right? So this is the same as 1/6, isn't it? So they would have a total of 1, 2, 3, 4. So 4 times 1/6 is equal to 4/6. And that's how we can look at this, right? Which brings us back to the original problem of 4 divided by 6. And we can write 4 divided by 6 as 4/6. We can just write that immediately. Obviously, that can be simplified as well, okay? So let's go ahead and look at each class gets 4/6 of a package, which that could actually be simplified down to 2/3, as we know. So let's look at numbers 1 and 2 here. So it says circle the number line you can use to solve the problem in the example. So which of these could we use as a model to solve this problem? So which one of these is modeling this problem of 4 divided by 6, right? So go ahead and circle the one. You should pause this, circle it. Okay, now that you've done that, let's just compare answers here. Well, let's look at A first. Well, A, what does this number line show us? This number line starts at 0 and goes out to 4, so it shows a total of 4. Each hole here is broken up into 1, 2, 3, 4, 5, 6 parts. So that means this is a total of 4 being divided into groups of 6. That sounds like this problem, doesn't it? So that's probably going to be the one we want to circle. But let's check B. What does B show? B shows a total of 6, and each one is broken up into 1, 2, 3, 4 groups, right? Well, this would be a total of 6 divided into groups of 4, right? So that's not what we want. We don't want that because that's the opposite. That would be 6 divided by 4, and what we want is 4 divided by 6. So this would be the one that we would want to use. Okay, now if we use this to solve this, it would quite literally just be that one, that one, that one, right? And that one. Those ones I just shaded there would be an example of the same thing as this, of these ones that are shaded here, right? Because this one hole right there would be the same as this hole right there. So 1, 2, 3, 4, 4 of them. And the idea is each one of these is 1 out of 6 of a whole, right? I mean, everything's in relationship to one whole, right? Of one whole. That is 1 out of 6, which is equal to 4/6, okay? Which is also equal to 2/3, right? Okay, but that's really where we're getting at here, okay? So look at the example again. Suppose only 5 classrooms share 4 packages. So now instead of 6 classrooms, we have 5 classrooms, but we're still sharing 4 packages. How would the model in the example change? How would this model be different if 5 classrooms instead of 6? And then how would this change the answer? Go ahead and write your answer. Pause this now, write your answer. Okay, so now that you're on pause, you should have already written your answer and done this. How would this model change? Well, hopefully you wrote something along the lines that instead of 6 groups here, it would be 5 groups, right? So we would break it up. Each rectangle, let's call it rectangle. Yeah, each rectangle would, can't spell, would be divided into 5 groups instead of 6, right? Okay, so it'd be 5 groups instead of 6, right? So instead of 6 groups up here, it'd be 5 groups instead, because we're dividing into fifths, because we're dividing them into 5 classes, not 6. Okay, so how would this change the answer? Well, the problem would be 4 divided by 5 now, right? That'd be the new problem, and therefore the new problem, 4 divided by 5, is the same as 4 fifths, right? Okay, that's what it would be. Obviously, if you need more time with that, pause it or go back in the video. You can control the video, go back in the video and then relook at it. Okay, let's look at number 3 then. Let's make sense of the problem first. It's a cute puppy. All right. So Trish is taking care of the Han family's dog. The Hans leave 7 cans of dog food for the 3 days that they'll be away. How much food will the dogs get each day if Trish feeds them an equal amount each day? Show your work, write the answer in remainder form and then as a mixed number. So let's make sense of it first before I tell you to pause. I'll tell you when to pause and get to work on it, okay? So she's taking care of the family's dogs, okay? The Hans leave 7 cans of dog food, okay, for the 3 days. So that's 7 cans to be used for 3 days. So what do we have? How much do we have of what we have? What we're dealing with is dog food. So we have 7 cans of dog food, right? That's what we have. And that dog food is going to be broken up evenly amongst 3 days. Okay, that's what we're trying to look at here. Okay, so how much dog food will the dogs, not each dog, just all the dogs. We don't even know how many dogs there are. Okay, but it's how basically she's rationing out 7 cans for 3 days. And she doesn't use all the cans in those 3 days, but in equal amounts. So she's rationing this out essentially. So go ahead and solve this best you can on your own. Pause this video now and do that. Okay. Now that you're on pause and you're back, you should have some work down here. Let's go ahead and compare your strategy to my strategy, and let's go ahead and make changes. Obviously, pause the video, make changes as I go along here as you see fit. Well, I have 7 cans for 3 days. So I know the problem is going to be 7 cans divided amongst the 3 days. This is my math problem, right? Well, if I'm understanding what I've been talking about here, I know that 7 divided by 3 is going to be 7 over 3, correct? Okay, 7 over 3, which again that's the answer, by the way. That's the improper fraction. That is the answer. Problem solved, I guess. But we want to make sure we write this in remainder form, and then we want to write it as a mixed number. So a lot of us can just look at that and quickly change this into a mixed number, right? Pretty easy. But let's go ahead and actually just model this real fast. You didn't have to model it if you saw this, but I'm going to model it just to again make sure that we're seeing this. I have 7 cans, right? 3, 4, 5, 6, 7, right? I have 7 cans, and they'll be divided into 3 groups, right? 3, 3, 3, 3, 3, 3, 3. And this would be day 1, day 2, day 3, right? So we just need to know how much it is for one day. So we'll take all of this, all of these thirds. We know that in one can, it's 1/3, right? And how many do we have? We have 1, 2, 3, 4, 5, 6, 7. So we have 7 times 1/3, and that equals 7/3. What do you know? It worked out. So we could just literally just write that as a fraction because it gets us to the same point. That's the point we want to see, is that it does get us there, right? Conceptually. I'm going to grab a different pen. This one's a little bit light. I apologize if that is hard to see. So that gets us to 7/3. Okay, so well, we can look at this and go ahead and divide this by just doing 7 divided by 3, right? Use our big 7 here. Again, we don't have to actually use the whole big 7. Hopefully you can do a lot of this in your head, but if you need to do this, we know that 3 times 2 is 6. You have 1 left over, so this would be 2, remainder 1. So that in remainder form, that would be your answer, right? 2 with the remainder of 1. As we've talked about in class already, if I was going to write this in fraction form, it would be 2 with 1 over 3, right? 2 and 1/3. That would be my mixed number fraction form, correct? Okay. Naturally, if I looked at this and I converted this, it would be the same thing. How many groups of 3 are there? Well, there's 2. And then what's left over? Well, 1/3 is left over, right? Okay. So hopefully that makes sense. Let's go ahead. Which best answers the question, the remainder form or the mixed number form? Which answer? We have 2 with the remainder of 1, or 3, 2 with 2 and 1/3. Now these are equal, right? These are saying the same thing. These are equal, man. But which one best answers this question? The remainder form or the fraction form? The mixed number form, I should say. Well, hopefully you're seeing that the mixed number form does, because it tells us exactly how much. It's telling us that 2 and 1/3 can. Okay. When you say the remainder, well, what does that even mean, right? What does that even mean exactly? Remainder of 1 can. It just gets a little more confusing, where it's 2 cans and 1/3 of a can is how much you would use for this day, right? And so the idea is that the mixed number, would answer it best because and this is where I want you to actually just put your thoughts in it. So instead of me feeding you why you think it is, I already just talked about it, but I don't want you just to be copying. I actually want you to do your own thinking here. But you could take what I already said, and if you forget what I said, you can always go back a little bit and re-listen to it. Okay. All right. Number 4 here. By the way, if you haven't finished the previous one, obviously pause this before you start number 4. Number 4, Raul plans to run 30 miles this week. He wants to run the same number of miles each day of the week. He says he will run 7/30th mile each day. Is he correct? Okay, so he wants to run 30 miles in 1 week. He wants to run the same amount of miles every day. So on Monday, Tuesday, Wednesday, every single day is run the same amount. Exactly the same amount. Is he correct if he's going to run 7/30th mile each day? Explain. So pause this now and answer this question. Okay. All right, welcome back. Is he correct? Let's start with there. Is he correct? No, he's not correct. So is he correct? Nope. Nope. But the reasoning behind this is, what I'm thinking about is, why is he not correct? Well, this is his answer, right? This is his answer, 7/30th. Well, how did he get 7/30th? Well, if he's looking at what he has 30 miles a week. He has 30 miles in a week, and there's 7 days in a week. And he wants to figure out how much will he run each day, right? Each day, okay? He wants to run the same amount each day, but how much will he run each day? Well, if I have 30, think about this. What do I have? What's my total, right? What's my total number of what I'm dealing with? And it's miles, and I have 30 miles, right? So that is, I'm gonna write it down here. So that is, if I have 30 miles, I'm going to divide that into 7 groups, because that will give me how many are in each day, because there's 7 days in a week, right? Well, like we talked about in the previous problem, no, I don't actually have to do division here, right? I don't actually have to do division here. If I just write this as a fraction, it'll be an improper fraction. I can still just write this as a fraction. It's gonna be 30/7, right? That's how many miles he's going to be running each day, is 37ths of a mile, right? Well, that obviously needs to be changed into a mixed number, which would be, again, how many groups of 7 are in 30? Well, 7 times 3 is 21. We can get another group, so 7 times 4 is 28. Can we get another group? No, so it's going to be 4. If 7 times 4 is 28, what's left over? Well, 30 minus 28 is 2, right? And 2/7. So that's what the answer should be. This is how many miles per day, right? Miles per day. So if you have this as part of your evidence, beautiful. It's math to support your reasoning, right? But also you should have a little bit of an explanation. Is he correct? No. Why? Because he got his answer by using this equation. This is the equation he used. He did 7 divided by 30, didn't he? Didn't he? Okay. Whoops. That's the equation that he used, okay? He should have done this. I don't want to rewrite it. So obviously you shouldn't just copy exactly what I did. You should have your own thinking in words and paraphrasing your own words. Okay. Okay, go ahead and pause this if you're still working on it. I'm moving on. Okay. Last problem of the day, for the day today, is Gus makes 48 fluid ounces of spiced cider. If he serves an equal amount to each of 7 people, will each person get more than 1 cup of cider or less than 1 cup? Okay, and again, 1 cup is equal to 8 fluid ounces. Show your work. Here's where you should pause it and go ahead and get to work. Okay, so let's go ahead and look at this. Now, there's a couple different ways we can solve this. Let's just go ahead and use some math to prove that this works. Again, you guys might think about this in a lot of different ways. I have 48 ounces of spiced cider. That's what I have. Okay, he's going to service equal amounts to 7 people. Okay, so what equation am I going to be using for this? I'm going to take what I have, the total amount that I have, and I'm going to be serving it to an equal quantities to 7 people. So it's going to be 48 divided by 7 is going to be the equation, the expression that's going to represent this problem, right? The question though is, will each person get more than 1 cup? So is the answer to this more than 1 cup, right? Well, we know that there are 8 fluid ounces in 1 cup. So let's find out. Well, there's one way we can do this. We can go ahead and just do this. This turns into 48/7, doesn't it? Okay. Now, obviously, we can go ahead and just do some quick division here. Again, there's a lot, you can do it in other ways. I'm going to do it this way because I know a lot of kids will do it this way. Again, 7 times what equals something close to 48? Well, 7 times 6 is 42, right? And 7 times 7 is 49. So let's go and do 6. 42. Subtract, we get 6. So then we have 6 our answer is going to be 6. That's 6 there, right? 6. And this remainder of 6, but we're going to write our remainders as fractions, aren't we? So it's going to be, our remainder of 6 is going to be 6 over our denominator. I mean, our denominator is going to be our divisor. So it's going to be 6 and 6/7, right? Well, 6 and 6/7 is less than, right? 6 and 6/7 is less than 8, right? Because 1 cup is equal to 8 ounces, right? 8 fluid ounces. Okay, so 6 and 6/7 is less than this. So the answer is, the question was, will each person get more than 1 cup of cider or less than 1 cup? So the answer is less than 1 cup. Now, this is not the only way to solve this problem, obviously. There's other ways to think about this. You could obviously take in 8 fluid ounces and I did 48 divided by 8 to see how many cups you would have, right? And if you did that, so this is another strategy, right? If I did the 48 divided by 8, obviously with our understanding our multiplication facts, we're going to get an equal number of 6s. 6 times 8 is 48, right? If I think inverse operations. So that means I would get 6 cups, correct? Well, is 6 cups enough to feed 7 people 1 cup? No. 6 cups give 6 people 1 cup, right? And not even more than 1 cup, give them exactly 1 cup. So if I have 7 people, then I know I'm gonna have less than a cup, right? Another way to look at this, I know some of you solve the problem that way as well. Some of you guys would just think about it that way using related multiplication facts and things like that and just problem solving, which is an amazing way to do it. I love it, okay? But understand that there's multiple ways we can solve these problems and look at them, okay? I will be online, I won't be online today. Okay, I won't be online today on Friday. I won't be online on Fridays, but I will be back online Monday. Please, any notes that you have, circle things that didn't make sense. Even if you got the answer, you're stuck, I still don't understand that. Circle it. Come and see me Monday. I'll try to be online for an extra amount of time on Monday to try to answer some of those questions. So hopefully this helps as we move forward. Awesome. Okay. Nice work, guys. Talk to you later.